Hi, it's Dr. Z. In this video, I will introduce a new statistical test called the Z-test. By the end of this video, you'll be able to describe what is a Z-test, as well as be able to conduct a two-tailed Z-test using a Z-score for a single sample mean M. Please feel free to pause the video at any time to take notes on the chapter handout. Hypothesis testing is the heart of conducting research. In a hypothesis test, we conduct a research study with a sample and then decide if the sample supports a hypothesis about a population. Unfortunately, sometimes we do not know information about the population with which to make comparisons to. As such, a Z-test uses the distribution of means to help us make those comparisons. We can figure out what a Z-test is by simply breaking it down into its parts. First, the word test is referring to a hypothesis test. So we will use the 4 hypothesis testing steps that you learned in the previous chapter. Second, the Z is referring to a Z-score. So the definition of a Z-test is that it is a hypothesis test for a single sample mean. Our test statistic will still be a Z-score. Most importantly, we use Z-tests when we do know population variance, or sigma squared. More specifically, the Z-score will be for a sample mean. The previous hypothesis test that you learned was for a single sample X-score, or doing research on one person. We are now doing research with more than one person. This diagram illustrates the process of hypothesis testing. You learned how to conduct a one-tailed and two-tailed hypothesis test last week. We will use the same 4 steps in conducting a Z-test, with some modifications along the way. Step 1, the yellow Lego, is to state hypotheses. Guess what, my friends? Fortunately, this step stays the same as we learned last week in hypothesis testing. A friendly reminder to make sure to know whether you need to conduct a one-tailed or two-tailed test. The hypotheses that you write should reflect what type of test you are conducting. Step 2, the blue Lego, is where we use the hypothesis to predict the characteristics that the sample should look like if the study worked. In other words, we set the criteria to decide if the study worked or not to make a decision at the end of the study. Guess what? Yep, this step stays the same as we learned last week because the shape of a distribution of means is a normal distribution. You will use the same steps as before and use a normal curve table to find critical region Z. Step 3, the red Lego, is to collect data and calculate sample statistics. Step 3 involves math and corresponding formulas. The only modifications for a Z-test occur here in Step 3. We will use a modified formula because we are using a sample mean now and the distribution of means. This step now requires 2 parts. First, we will need to calculate mu-m, sigma squared m, and sigma m because we know population variance and need to use the distribution of means. Please see the Nearpod lesson for the lecture video that reviews the rules and formulas for calculating these components. Since this is a Z-test, we need to, of course, calculate a Z-score. So the second part of Step 3 is that we will calculate the Z-score for the sample mean. However, we will calculate the Z-score with this new formula. Well, really, this formula isn't that new. Notice that this is a modified version of the Z-score formula from last week's hypothesis testing. Last week, the m was an x, and there was minus mu divided by sigma. Well, now we're not doing a single score x, we're doing a sample mean, and we now need our distribution of mean, so instead of mu, it's mu m, and we're going to divide by sigma, but it's really sigma m. So it's a slightly modified formula, but it's very important that you use this formula and not last week's formula when conducting a z-test. Step 4, the green Lego, is to make a decision about whether the study worked or not. Guess what? This step stays the same. If you need a refresher, please see the lecture video in last week's Nearpod lesson that explains these two decisions. Now that we reviewed the steps of a z-test, are you ready to practice your new knowledge? I have one lecture example for you to review. This is a summary of the 4 steps that we described earlier in this video. Please note that these steps are for a two-tailed z-test. The one modification for this test is noted in bold here in step 3, where you will have 2 parts to calculate. Please pause the video to write down these steps on the chapter handout. This lecture example wants to know if being told positive personality qualities will affect physical attractiveness. Since we do not know what effect positive personality qualities will have, we will conduct a two-tailed test with non-directional hypotheses. The details of this research study are provided in your chapter handout. This research study is telling positive personality qualities to the sample. The positive personality qualities are the independent variable, which is being manipulated by the researcher. Physical attractiveness is being measured to determine if being told positive personality qualities worked. Physical attractiveness is the dependent variable. In this research study, a sample was told positive personality qualities while looking at photos of individuals. The sample was then asked to rate those same photos on physical attractiveness. The general population has a physical attractiveness rating of mu equals 200 and sigma equals 80, which forms a normal distribution. I encourage you to pause the video here and try to do the 4 steps on your own first. Then resume the video to show the answers. Step 1. The null hypothesis is predicting that there will be no difference in physical attractiveness between the sample that was told positive personality qualities and the population who did not. The words physical attractiveness are underlined here because it is the dependent variable, what is being measured in the study. The words positive personality qualities are also underlined because it is the independent variable, what was being manipulated in the sample. Since the treatment in this study was being told positive personality qualities, I shorten it to PPQ. In notation, the null hypothesis would be mu PPQ equals 200. In other words, if we could tell the entire population about the positive personality qualities and nothing happened, then the treated population should equal the population mean. In the lecture example, the population mean is mu equals 200. So we will place the numerical value of the population mean in the notation. The research hypothesis will reflect that there is a difference on physical attractiveness between the sample that was told positive personality qualities and the population who did not. In notation, mu PPQ does not equal 200, meaning that if we could tell the entire population about the positive personality qualities and something happened, the treated population should not equal the population mean, mu of 200. Step 2. As a researcher, we get to decide the significance level, and the preferred one is 0.05. Since we do not know if being told positive personality qualities are going to increase or decrease physical attractiveness, we need to draw a critical region for both tails, above and below the mean. The corresponding z-scores for a 0.05 significance level two-tailed. The box indicates the final answer that I'll be looking for on problem sets and exams. Step 3. Since we do know population variance, we need to use distribution of means for our calculations. This step has two parts now. First, we will use the rules and formulas to calculate mu-m, or the mean of distribution of means. Then, sigma squared m, or the variance of the distribution of means. And finally, sigma m, which is standard error. The second part is that we will use the modified z-score formula that allows us to compare our sample mean with mu-m and sigma m. Using the formula, we will plug in the values for the sample mean m, 220, that is given in the lecture example, and then we'll plug in the values for mu-m and sigma m that we calculated here in the first part. The z-score for the sample is z equals +2. The box indicates the final answer. Now, I want you to think like a researcher. What does this z equal +2 mean? Well, the plus sign indicates that it is above the mean, or that there is an increase. Our dependent variable, or the variable that we were measuring, was attractiveness. So the z-score means that being told positive personality qualities appears to increase attractiveness. This initial interpretation of the z-score value is critical in writing summary and interpretation statements. Step 4. Now we need to make a decision to determine whether the study worked or not. In this step, we will compare the sample z-score calculated in Step 3 to the population prediction determined in Step 2. In other words, does the z equal +2 that we calculated in Step 3 fall in the critical region Z? Using the graph, we can see that the +2 falls in the tail past z equals +1.96. Meaning, my friends, the answer is yes, it does fall in the critical region. Then the decision is to reject the null hypothesis. The box indicates the final answer that I'll be looking for on problem sets and exams. Thinking like a researcher, what does it mean to reject the null hypothesis? This decision means that the study appears to be statistically significant. Again, this initial interpretation of the decision is critical in writing summary and interpretation statements. After a z-test is conducted, a researcher must report and interpret the results of the study. So, let's practice those summary and interpretation statements. I encourage you to pause the video here and try to write the statements on your own first. Then resume the video to show the answers. The summary statement will consist of 2 sentences. The first sentence will report the mean of the sample. Please note that this first sentence clearly states how the sample was being manipulated by being told positive personality qualities, which is the independent variable, and what is being measured in the study, which is physical attractiveness, the dependent variable. The second sentence will report the z-score, the significance level used, and the decision you made. Please note that we never say that we rejected the null hypothesis in the statement. Instead, we use the phrase p is less than 0.05 to let our audience know that the decision is to reject the null hypothesis. Since the z-test was statistically significant, the interpretation statement will only be 1 sentence. This sentence clearly states that we measured an increase in physical attractiveness as initially interpreted in Step 3. If you need a refresher on writing summary and interpretation statements, I encourage you to re-watch last week's lecture video on reporting results and reviewing your Nearpod practice problems. In summary, research often involves using samples where we do know the population variance. A z-test uses a distribution of means to help calculate the z-score for the sample mean. Learning how to conduct a z-test for a single sample is one more major Lego building block needed to understand statistics.